Welcome to another physics class. In our last discussion, our topic is motion under gravity. And by then, we concluded that when an object is thrown vertically upward, like this, definitely it will reach a maximum height before it falls back to the ground. We explained by then that on moving up, it will have negative acceleration due to gravity. And this negative acceleration due to gravity is due to the fact that the velocity of object as it's moving up before it reaches the maximum height is gradually decreasing. At the same time, when it reaches the maximum height at this top point, that the velocity here, final velocity here is equal to 0. On coming down, the same object, the fact that it faces the direction of the acceleration due to gravity, g, the velocity is increasing. Therefore, we have positive acceleration due to gravity. So, by then, we now use this one to derive the equation of an object under gravity. That the first equation that we are going to have is V is equal to U plus or minus gt. Second equation will be H is equal to ut plus or minus half gt square. And the last one will be V square is equal to u square plus or minus 2gh. Don't forget, we've explained how we got all these formula, that is from the linear equation of motion. I explained by then that from linear equation of motion, the equation 1 is V is equal to U plus or minus AT. This our is linear acceleration. And since we are dealing with motion under gravity, gravity will have effect on this one. That is why our linear acceleration is now changed to g. Again, the second equation under linear motion is S is equal to ut plus or minus half at square. The same thing applicable to this one. This is horizontal distance. And since we are talking about vertical distance here, we change our S to H. Due to equation 3, which is equal to V square is equal to U square plus or minus 2GH. 2AS from linear equation of motion. Linear acceleration, horizontal distance, we now change to acceleration due to gravity and vertical distance. Now, having done that, explain all this one by then, we now say that today we are going to make use of this equation under gravity to solve some problem today. That is, all these equations, the three equations we have on the board for an object falling under gravity. We want to use this equation to solve some problem today. That is our promise. And don't forget, if you are still joining us under this channel, please try to like, share, and subscribe so that when I have a new video like this, you're able to get the notification in time. Now, let's take this question as example 1. A rocket ball is thrown vertically upward with an initial velocity of 40 meters per second. Calculate the 1. Velocity after 3 seconds. 2. Maximum height attained. 3. Time taken to reach the maximum height. 4. Time taken to fall from maximum height to the ground. And 5. Total time taken by the ball to hit the ground again. Now, to solve this one now, let's take it one after the other. Question Roman figure 1. Velocity after 3 seconds. Velocity after 3 seconds. Now, let's write the parameter given in this question. 1. 40 meters per second as the initial velocity. So U is given as 40 meters per second. Then, according to the question, G is given. That is the major influence. Acceleration due to gravity, 10 meters per second square. Then, the question says velocity after 3 seconds. Time is given. Time, 3 seconds. So, from there now, to calculate the velocity after 3 seconds, let's come back to our formula. This is for linear motion, while this one is for motion under gravity. The question says velocity after 3 seconds. It means, according to this diagram, this rocket ball now has not reached the maximum height, but it moved from the horizontal level to a certain velocity, and we have been given the time, which is 3 seconds. So to calculate the velocity after 3 seconds now, we are going to apply this equation 1. We say that V is equal to U minus GT. And why is it minus? Because the question says the ball is thrown vertically upward. And I told you, when it's thrown vertically upward, acceleration due to gravity G will take a negative value. So that is why we have minus G. Now, we want to calculate the velocity. U is already given after 3 seconds, and G is given, so it will now give us 40 minus 10 multiplied by 3. So from there now, we are going to have 40 minus 30. And this one, velocity after 3 seconds, will now give us 10 meters per second. That will be the velocity after 3 seconds. The 10 meters per second, so definitely that the velocity is decreasing. Look at the velocity that the ball started with, 40 meters per second. It moved up. After 3 seconds, the velocity has reduced to 10 meters per second. So according to our explanation, we can now say that the velocity is gradually decreasing. That is for question number 1. Now for question number 2 now. We say the maximum height reached. Maximum height reached. Now, question number Roman figure 2 under it. Maximum height. Maximum height. And according to the equations, look at the 3 equations on the board. The one that contain maximum height is equation 2 and 3. And if you look at equation 2, this T is time taken to reach the maximum height. The time given there is velocity after 3 seconds. So this one has not reached the maximum height. But equation 3 is equal to V square is equal to U square plus or minus 2GA. That's so that we are going to apply equation 3. Equation 3, V square is equal to U square minus 2GH. And as I said during our last discussion, at maximum height, V is equal to 0 at maximum height. And already u is given from the question, that's 40 meters per second. So it will now be 0 square is equal to 40 square minus 2 multiplied by 10 multiplied by 8. Why is it minus? According to the explanation, because the ball is moving up, then negative value of g. That is why it is minus, not plus. Now from there, now we can now have 0 will be equal to 1600 minus 28. So from there now we are going to have 28 will be equal to 1600 minus 0. So this one will now give us 20 is equal to 1600. 8 now will be equal to 1600 divided by 20. Therefore, our maximum height, according to the question, will be equal to 80 meters. That will be the maximum height raised by the rocket ball. Now, Roman figure 3 question. Roman figure 3. That is time taking to reach the maximum height. Let's look at the equation again. Time taken to reach the maximum height. We can use equation 2. We can use equation 3. But the possible equation that we can use is equation 1. And this one will now give us V is equal to U minus GT. Don't forget, our V remains the same. V will be equal to 0 at maximum height. If V is equal to 0 now, and U is given, so we can now have 0 is equal to 40 minus 10t. Therefore, our 10t now be equal to 40. So from there now, t will now be equal to 40 divided by 10. Therefore, time to reach the maximum height will be equal to 4 seconds. 4 seconds. Now, Roman figure 4. As the time taken for the ball to fall from maximum height to the ground. That's Roman figure 4. Time taken to fall from maximum height to the ground. Let's come back to our equation again. Time taken for the ball. This is the maximum height to fall from maximum height to the ground. Equation 1 is not suitable. We can only use equation 2. The reason for using the equation 2 is that we've already know the maximum height, h. So we can now apply equation 2 by saying h is equal to ut. Now, is it plus or minus now? It should be plus. Why? Because the question says to fall from maximum height to the ground. The object is coming down now. That one will be plus half gt squared. What do we need? Time taken to fall from maximum height to the ground. So let's make t the subject of the formula now. So our u, according to the explanation during our last lesson, is when the object is coming down from maximum height, u will be equal to 0. That is falling from maximum height. So u will be equal to 0. If u is equal to 0, then this term will be equal to 0. Then we are now left with h is equal to half gt squared. Half gt squared. So this one will now give us 2h will be equal to gt squared. Our t now square will be equal to 2h over g. So t now will be equal to square root of 2h over g. And this one will now give us, since our h is 80, so that will be square root of 2 multiplied by 80 divided by 2. Divided by 10, the value of acceleration due to gravity. Now, from there now we can now say t now is equal to 160 over 10. That is 2 multiplied by 80, that's 160. So from there now, we can now say that will be square root of 16. So this one will now give us 4 seconds. Now you can now notice something, that time for this ball to reach the maximum height is 4 seconds. At the same time, time to fall from maximum height to the ground is also 4 seconds. It means when an object starts from this horizontal level and move up like this and come back to the same horizontal level, the time taken by the object to reach the maximum height will be equal to the time taken for the same object to fall from maximum height to the ground. That is 4 seconds to reach the maximum height. To fall from maximum height to the ground, the same 4 seconds. Once the motion is under the same horizontal level. Now, the last question under is Roman figure 5, total time taken. To calculate the total time taken, according to my last explanation, since the object is moving under the same horizontal plane, so we can now say our t is equal to 2t. Once it is moving on the same horizontal level. And what is our t? Our time is 4 seconds. That will be 2 multiplied by 4. Then it will take 8 seconds to start from here and come back to the same horizontal level. That's all for that question. As I said earlier, if you are just joining us under this platform, this topic is just a continuation. For you to understand it better, please try to like, share, and subscribe so that our last lesson will be able to given to you under the notification. Now, let's take this one as example 2. A tennis ball is thrown vertically upward from the ground with a velocity of 50 meters per second. Calculate the 1. Maximum height reached. 2. Time taken to reach the maximum height. 3. Time of flight. Solution. Let's first write out the parameter given in the question. Now, the velocity, that is u, is given 50 meters per second. Again, what else is given? So according to the question, you say g is equal to 10 meters per second squared. So g is equal to 10 meters per second squared. That's all. Now the first question says to calculate maximum height. So don't forget our formula without wasting our time. If you write the 3 formula here, V is equal to U plus or minus GT. The second one, H is equal to UT plus or minus half GT square. Then the third one, v square is equal to u square plus or minus 2gh. Now, looking at the three formula now, according to the parameter given, the question asks us to calculate maximum height. It means we can only use equation 3. This one cannot be used because time is not given. Dictate to equation 1. So, apply v square is equal to u square. Since this object is going up, we stick to negative sign minus 2gh. What do we need? 8. So make 8 the subject to the formula. Then we are going to have v square minus u square is equal to minus 2gh. Now, don't forget in our theory that at maximum height, what the value of v? V is equal to 0. If v is equal to 0, then we are going to have minus u square is equal to minus 2gh. Minus will cancel minus. So we are going to have u square is equal to 2gh. So our h now be equal to u square over 2g. And what is the value of our u? 50. That will be 50 square over 2 multiplied by 10. Then this one will give us 2500 over 20. So h now will be equal to, that will be 20, 0 will cancel 0. That will be 250 over 2. Now our h will be equal to 125 meter. So Roman figure 2, time taken to reach maximum height. Time taken to reach maximum height. Now, from what is on the board now, we can apply equation 1. We say that v is equal to u minus gt. Don't forget why it says minus. The object is thrown up vertically. So our v, according to the question, is 0. U is given as 50. So, but we need t. So we are going to have, v minus u is equal to minus gt. V is equal to 0 as usual. Why? At maximum height. Don't forget, at maximum height. V is equal to, so we are going to have minus u is equal to minus gt. So minus will cancel minus. So you have your t now is equal to u over g. What is value of u? 50. Then g is 10 over 10. So time to reach the maximum will be equal to 5 seconds. Now, the last question, which is Roman figure 2, time of flight. Mind you, time of flight is the same thing as total time taken. Total time taken. So to calculate total time taken, now that's Roman figure 3, time of flight. Time of flight, which is capital T. And according to the formula given in the last question, that will be 2t. So, and our t is 5. So we are going to have 2 multiplied by 5. That will be 10 seconds. So it means time of flight or total time taken will be equal to 10 seconds. Now let's take this one as example 3. A stone is projected horizontally at 15 meters per second from a height 20 meter. Calculate the horizontal distance covered by the stone on hitting the ground. Now, from this question now, let's list the parameter given. 1. U is given, that is the initial velocity, 15 meters per second. height from which it's being thrown, h is 20 meter and g is 10 meter per second square. For better understanding, let's put it into draw. Let's say this is the height from which the stone is being thrown, 20 meter. This is horizontal ground, so it is thrown like this with a velocity of u 15 meter per second. And the question now asks us to calculate the horizontal distance covered, that is from here to here. So let's call it x, or let's use another symbol, x. That's horizontal distance covered. So now say x is equal to horizontal distance cover. If that is the case, now if you look at this question now, this question has joined motion under gravity with linear motion, because it is under linear motion that we talk about horizontal distance. So once this question has joined the two topics together now, we need to solve it. But don't forget, in our linear motion, what's the formula for horizontal distance? We have this formula as x is equal to ut plus or minus half at squared. But mark you, as I said, the question has joined both topics together. So we are dealing with motion under gravity, horizontal distance coming. So this one will be g. Now, if this is the case now, then don't forget, under this one, there is no horizontal acceleration. That is, when you are moving linearly, that is, with horizontal distance, g is equal to 0. G equal to 0. Why? No horizontal acceleration. So in that case, acceleration due to gravity will be equal to 0. If that is the case now, so this term will be equal to 0. We are now left with s is equal to ut. And mind you, we are saying our s will be what? X. We can now say but s is equal to x. So we can now say s is equal to ut. And this t, don't forget, is time taken to reach the maximum ground, the time to fall to the horizontal ground, So from there now, let's now apply the suitable formula by saying h is equal to ut. H is equal to ut. It will be plus now half gt squared. H is equal to ut plus half gt squared. And don't forget our theory that when an object is falling from certain height to the ground, the value of u will be equal to what? 0. U will be equal to 0. Why? Because the object is coming down. So if u is equal to 0 now, that is when we apply this one to horizontal distance. That is why our u is 15 meter per second. But when you now apply it to motion under gravity, as I said, the question, join the two topics together, then our u will be equal to 0. when that object is coming down. So if u is equal to 0, we are now left with h is equal to half gt squared. So therefore, we are going to have 2h is equal to gt squared. So making t the subject of the formula, we are going to have t now square will be equal to 2h over g. So t now is equal to square root of 2h over g. So our h that is given in the question is 20, while g is 10. So we are going to have t is equal to square root of 2 multiplied by 20 over 10. So that will be square root of 40 over 10. And 0 will cancel 0. So we are going to have as t is equal to square root of 4, where t is equal to 2 seconds. That is the time taken now for this object to fall from maximum height to the ground is 2 seconds. This is meant for the t we have here. That is time taken for the object to fall to the horizontal ground. Now, once you know the value of t now, so our s now, which is horizontal distance now, our s now will be equal to ut. What is our u? Don't forget, this question brought the two topics together, that is linear motion and motion under gravity. So we are going to have 15 multiplied by 2. So the horizontal distance covered by the stone now will be equal to 30 meters. Let's take this one as example 4. A stone is projected horizontally from the top of a tower with a speed of 5 meters per second. It lands on the ground level at horizontal distance of 2 meters from the foot of the tower. Calculate the height of the tower. Normally, our g is 10 meters per second square. So, let's write out the parameter given. Solution. Here now, speed is given, which is u, as 5 meters per second. Then again, g is given, g 10 meters per second, and that's all. The question asks us to calculate the height of the tower. Let's draw it and see, as we did the other time. Let's say this is the height of the tower. Then this is the horizontal level. It travels like this, coming down. According to the question, the horizontal distance is 2 meters. This is the foot of the tower, and the speed, horizontal distance, x, is given as 2 meters, and the speed at which this thing is moving, u, is equal to 5 meters per second. So we have to calculate the height of the tower. Now, the first thing we need to do to calculate the height of the tower, this question is like the other number 3 question that we saw, in the sense that it combines the linear motion with the motion under gravity. And when you say height now, it will be equal to h is equal to ut plus half gt squared. H is equal to ut plus half gt squared. Now, the other time is calculated. Here now also time will be calculated. So you can now say, let's write the second formula. S is equal to ut plus half gt squared. Why I say g? because as I told you, it combines the two topics together. So since there is no horizontal acceleration that we said the other time, this one will be equal to 0. So G equal to 0. Now, to calculate our T now, that is time taken to fall from this height to the ground now, then it will now give us S, that is the horizontal distance given, as UT. Now, U is already known. What do we need? T. So you now see T now is equal to S over U. And what is our S? 2. What is our U? That will be 5. Now, this one will now give us 0.4 seconds. Once we know that our T is 0.4 seconds. Now, to calculate the height of the tower now, that is H is equal to UT plus RGT squared. Now, don't forget that from our theory, when an object is falling down from certain height, definitely our H is equal to UT plus half GT squared. When it's falling from certain height, U will be equal to 0. So if U is equal to 0 now, don't forget our reason, falling from maximum height to the ground. Then we are now left with H is equal to half GT squared. And what do we need? The height of the tower. So this one will now give us half multiplied by 10 multiplied by 0.4 squared. So our H now will equal to 2 here, that's 5 multiplied by 0.16. Therefore, our final answer for the height of the tower will be equal to 0.8 meter. 0.8 meter. That will be the height of the tower. Now, let's take this one as example 5. A stone is drawn from a height 80 meters above the ground. Calculate the 1. Time taken to hit the ground. 2. Velocity of the stone on hitting the ground. As usual, let's write out the parameter. Height is given. Height, H is given, 80 meters. G is given, 10 meters per second square. Then we now have to calculate the time, because this stone is drawn from certain height. The height is 80 meters. We have to calculate the time on hitting the ground. So our formula remains the same without wasting our time. As you know, the three formula is always the same. But which one will be stable to solve this one now? That will be equation 2. That is, H is equal to UT plus Y. It is coming down, half GT squared. And don't forget, when it is coming down, just repeating theory, U is equal to 0 when the object is coming down. If U is equal to 0, then this term will be equal to 0. We are now left with A is equal to half GT squared. What do we need? T. So from there, we can now say T squared be equal to, yes, that will be equal to, let's cross multiply here. That's 2H is equal to GT squared. So T squared now will be equal to 2A over G. If that is the case, then we are going to add T now is equal to square root of 2H over G. Our H is 80. That's multiplied by, divided by 10. So that is 160 over 10. Then this one will now, T now is square root of 16. t is equal to 4 seconds. That's the velocity, time taken to hit the ground. Now, the second question say we should calculate the velocity on hitting the ground. Velocity on hitting the ground. Now, out of the three questions, we want to calculate the velocity on hitting the ground. Now, we are going to apply equation 3. And equation 3 says that v squared is equal to u squared hitting the ground plus 2g8. Mind you, height is already known. So if height is already known, and on coming down, don't forget, u remain the same. U will be equal to 0. When from the initial state, when it is coming down, if u is equal to 0, then we are going to have v squared is equal to 2g8. This one will now give us square root of 2g8. And what is our age? According to the question, that will be 2 multiplied by 10. Our age given from the question is 80. So this one will now give us, that's 20 multiplied by 80, that is 1,600. What is the square root of 1,600? The final answer for velocity on hitting the ground will be 40 meters per second. 40 meters per second when the stone hits the ground level. This one as question 6. A ball is projected vertically with unknown speed and returns to the same level 5 seconds later. Calculate the initial speed of the ball. 2. Maximum height reached by the ball. G is equal to 10 meters per second square. Let's write out the parameter first. Now, the initial speed, u, is unknown. Time taken, t, capital T, is known, 5 seconds. Then g is given, 10 meters per second square. Now the first question asks us to calculate the initial speed. To write our formula down, this body is projected vertically upward. That would be v is equal to u minus gt. V is equal to u minus gt. Don't forget, the v will be equal to 0 at maximum height. Because the question says we should calculate the maximum. So at maximum height, v will be equal to 0. Then we have to calculate u. G is given as 10 meters per second. Now, don't forget, capital T is given, that is time taken to return. So that one will be equal to T now be equal to 2T. So our small t there equal to what? Capital T over 2. That will be 5 over 2. So will give us 2.5 seconds. If that is the case now, to calculate u now, if you now give us 0 is equal to u minus 10 multiplied by 2.5. So our 0 now will be equal to u minus 25. Therefore, u will be equal to 25 meters per second. Now question 2, maximum height. Maximum height. Apply equation 3 also. That one will now give us v squared is equal to u squared minus 2gh. At maximum height, don't forget our V remains the same 0 at maximum height. Already the value of U is known. So we need H. Make H the subject of the formula. So this one will now give us V squared minus U squared is equal to minus 2GH. So this one will now give us, this one is 0, that will be minus U squared will be equal to minus 2GH. Minus will cancel minus. So H now will be equal to U squared over 2G. So if that is the case, then our H now will be equal to 25 squared over 2 multiplied by 10. For 625 divided by 20. So H maximum height will equal to 31.25 meter. That's the answer. Now let's take this one as example 7, which will be last example under this topic. A stone is projected vertically upward with a speed of 30 meters per second from the top of a tower of height 50 meters. Neglecting air resistance, calculate the 1. Maximum height reached by the stone. 2. Time taken to reach the maximum height. 3. Time of flight. 4. Horizontal distance covered by the stone. G, as usual, 10 meters per second squared. Now, this question is totally different from what we have been doing before, and it will take the same process. So let's solve it accordingly. So from the question as read, let's draw it. So let's say this is the height of the tower, 50 meters. This stone was thrown from the top of the tower, reached the maximum height, and come back to the horizontal level. Now you can now say that, as I said the other time, this question is different from the one we have been solving, in the sense that here now we have to calculate time of flight. T is equal to 2t. That's what we have been doing. But here now, t cannot be equal to 2t because the motion starts from the top of the tower and ends on the horizontal ground. So it cannot be 2t. The way we are going to do it, let's go and you will see. The initial speed is 30 meters per second. Now, to calculate the height now, the maximum height now, raised by this stone from the ground. Now, the first thing we need to calculate, we calculate the height of the stone. The height of the stone from the top of the tower. Let's call it h. And if we want to calculate it h now, using our formula, then we are going to say v squared is equal to u squared minus 2gh. We need that h. So from there now we can now say at maximum height, v is always 0. So we are now left with u. So it will now be v squared minus u squared, is equal to u squared minus 2gh. So from there now, we can now say v squared minus u squared equal to minus 2gh. This one is 0. Then we are going to have minus u squared is equal to minus 2gh. Minus will cancel minus. So we have our g now, our h is equal to u squared over 2g. Mind you, from the question, u is 30. So we are going to have 30 squared over 2 multiplied by 10. So this one will now give us 900 over 20. And 900 over 20, h will now be 45 meters. If h is 45 meters, and we need the maximum height of the stone. The maximum height of the stone now, according to the question number 1, maximum height of the stone, call it h. H will now be equal to height of the tower plus height of the stone from the top of the tower. That will be 50 plus 45. This one will now give us 95 meters. That is the maximum height of the stone from the ground. That's question number 1. Then question 2. Time taken to reach the maximum height. Time taken to reach the maximum height. To calculate the time taken, now use the first formula. V is equal to U minus GT. V is equal to U minus GT. V equal to 0 as usual because it is thrown up at maximum height. V is equal to 0. So we are now left with 0 now is equal to 30 minus 10 multiplied by t. So that will be 0 is equal to 30 minus 10t. 10t now will be equal to 30. T now is equal to 30 over 10. So t now will be equal to what? 3 seconds. That is time taken to reach the maximum height. Now, question 3 says time of flight. Time of flight. That's question 3. Time of flight. Mind you, here now the time of flight, as I said the other time, cannot be 2t. Why? Because the motion started from the top of the tower, landed on the horizontal ground. So they are not at the same level. So the first thing we need to do now is to calculate time to fall from maximum height to the ground. When we arrive at the answer of that one, we now add it to time to reach the maximum height from the top of the tower. I take it again. Time of flight now, under this one will be equal to time to fall from time to fall from the ground plus time to reach the maximum height. And we've calculated time to reach the maximum height as 3 seconds. The next thing to calculate time to fall from maximum height to the ground. Now, time to fall from maximum height to the ground. Time to fall from maximum height. Don't forget our usual formula. Our usual formula is equal to T, without wasting time. T is equal to square root of 2h over g. We've used this formula several times. That is why I wrote it out like that. T is equal to square root of 2g over g. Or if you want me to express further, no problem. Let's express further how we arrive at this formula. It is from the second equation. Now when we say h is equal to ut plus, why is it plus? It is coming down. Half gt squared. So half gt squared. Mind you, when the object is falling down, u is equal to 0 when it is falling down. And we are now left with h is equal to half gt squared. This one will be 2h is equal to gt squared. So t squared now is equal to 2h over g. Finally, we are going to have our time to fall from maximum height to the ground as square root of 2h over g. That is the formula I wrote here, which we intended to apply. Case now, but take note. The maximum height here, as we calculated, is 95. That is height from here to here, not from here to here. So we can now say that T is equal to square root of 2 capital H over G. So this one will now give us 2 multiplied by 95 over 10 all into square root. This one will give us 190 divided by 10 all into square root. So this one will now give us time to fall from maximum to the ground will now give us square root of 19. Now, this one will now give us 4.3589. Approximately, this one will now give 4.4 seconds. That's time to fall from maximum height to the ground. Now, time of flight now. Time of flight will now be equal to time from the top of the tower, which is 3 seconds, plus time to fall from maximum height to the ground. That one will now be equal to 3 plus 4.4. And this one will now give us 7.4 seconds. You can now see the difference from the one we have been doing now. When they are the same horizontal level, the motion starts from the same horizontal level and end on the same horizontal level. Then you say your t is equal to, capital T is equal to 2t. But when it is not like that, you need to resolve, calculate the time to reach the maximum height first, then calculate the time to fall from maximum height to the ground. Then you now add the two answers together to give us the final time of flight. So this one will give us 7.4 seconds. Now, the last question, which is horizontal distance. Horizontal distance. Horizontal distance. That is from here to here. And I said the other time, the horizontal distance, S is equal to UT without wasting our time. If you say plus half GT squared, then G is equal to 0. So this is what we are going to let with. Now, our U is given. And at the same time, we calculated our T. Mind you now, the time taken now will be time taken to cover, to reach the maximum height plus time taken to fall to the ground. So that one will now give us S will equal to U capital T. So that one will now give us, that's 30 multiplied by 7.4. Now, finally, S, that is the horizontal distance, will be equal to 222 meters. And this will be the convenient point to stop on the work example on motion under gravity. And if you go through all this calculation and solution that we are provided to all the questions, I believe you should understand this topic and both the theoretical aspect and the calculation aspect of this topic. And if you still have any problem pertaining to this topic, as I always say, please send your question under the comment section, or you use the WhatsApp link put under this channel. And as I said earlier, if you are just joining us on this channel, please don't forget to like, share, and subscribe. So when I upload a new video like this, you will be able to get the notification